What do we remember about 2D shapes? So 2D shapes, two-dimensional, they're flat, basically talking kind of length, width idea. You haven't got that third dimension of depth. What do we remember? Give me some examples even. Yep, Ruby. Okay, so when we talk about a 2D shape, an example of a 2D shape is a square. Now, a square is part of a group of 2D shapes. What's the group of 2D shapes that the square belongs to? Rectangle's another example that's in this group. Start with Q. Yeah, so they are quadrilaterals. Square, rectangle. What else? Give me the other quadrilaterals. Rhombus, trapezium. What else? There's 6 fancy quadrilaterals. 2 more to go. Parallelogram, yep. What else? Trapezium's there. Sorry? Rhombus is there. Starts with K. Kite. Okay, so we've got the quadrilaterals, and obviously if they're not one of those, they are called irregular quadrilaterals. So these are all our regular ones, or kind of ones that we are familiar with. If it's not one of those, they're irregular, and the irregular ones are set up into, that's not really an ideal drawing, but there's 2 types of irregular ones. There's kind of that type, or there's this type. What's the difference between them? Does anyone know? Where one of the angles caves in? Yeah, that's a concave one. Anyway, that terminology probably not that important, but knowing the quadrilaterals. What else? What other 2D shapes have we got? Sorry? Polygons. Okay, so polygons are an overarching group of shapes that are 2D. They are defined by what? What can we say? What's the definition? How do we define a polygon? It is a flat 2D shape, but it has one specification. What is it? Yeah, it's got to have straight sides. Or sides, not sides. So yeah, it's got to have straight sides. So we looked at quadrilaterals. There's another group that we haven't talked about, which have the 3 straight. So the quadrilaterals are the 4. What about the 3? Yeah, they're the triangles. They're the easier ones. What are the types of triangles? Scalene, isosceles, equilateral. And triangles are also defined by their angles. So we could have obtuse or right angle triangle or acute angle triangles as well. So they all form part of the polygons. And then what else? So you've got triangles, quadrilaterals. So what else? After 4-sided, we've got 5-sided. What are they? Polygons. What are they called? Starts with P. Famous building in America. Pentagon. And then if we go 6-sided, we've got what? Hexagon and so on. Right? We could keep going on and on. But they are all polygons. So they are all shapes with straight sides, but not all 2D shapes have straight sides. Can you give me an example of a 2D shape that doesn't have a straight side? Circle, yeah. Sphere is 3D. So yeah, so then we've got other options. You've got circle, yeah, oval. Any others? Ellipse, yeah. An ellipse is like an oval shape, yep. Anything else? A crescent. Yeah, so circle, you've got, that can be split up into, you know, semicircle, etc. You've also got linking to circles, annulus. Do we know what an annulus is? So that's like a flat donut shape, like that. So circle within a circle, and then this is the annulus part. Okay, anyway, there's any others? Can't think off the top of my head right now. But basically, what you should also remember about 2D shapes, we focus mostly on triangles and quadrilaterals, and in particular the special qualities or properties about them is probably a better word. So how can we distinguish between a square and a rectangle, for example? What's the big difference? Yeah, a square has all the same sides, a rectangle not necessarily. In fact, a square is a special type of rectangle. So a square is a rectangle, but it has more properties than just the basic rectangle. Whereas and a rhombus is also a square, but it's not a rectangle. How do we distinguish between that? Sorry, I'll take that back. A square is a rhombus, but a rhombus is not a rectangle. Why not? Rhombus, has a rectangle has all right angles, whereas a rhombus does not unless it's a square. So those sorts of properties you should be familiar with from your work in previous years. Okay, let's go. We're going to spend a few minutes just filling in the blanks to remind us of these properties of these certain 2D shapes. Have a go. You've got a list of names of words that you can put in. All right, so you should remember these properties about triangles. You've got triangles can be classified according to the length of their sides. 3 sides equilateral. It also has 3 angles equal, and each angle 60 degrees. Now we know that because the sum of the angles in a triangle is 180. So if all 3 angles are the same, then they've all got to be 60 each. Isosceles we already talked about, also two sides and 2 angles. So the angles of the isosceles triangle are what we call the base angles. So if those 2 sides are the same, the base angles are the same. So those angles, base, sides, I guess is the important thing there. And then scalene, the ones where you've got no sides equal, no angles equal. All right, then also we talked about triangles and the connection to the size of their angles. So all angles less than 90 is the acute angled ones. Obviously, one angle between 90 and 180 is the obtuse. And then a right angle triangle has 190 degree angle. All right, moving on to the quadrilaterals now. I'll give you time to fill that in. Parallelogram to start with. The first one's a parallelogram. What can you tell me about this angle and that one? Just by looking at it. Should be obvious, they're the same. And this one and that one, also the same. So that's helpful. The side lengths, that side and that side, are the same. And they're the same as well. So there's a couple of just simple properties. Also with the parallelogram, opposite sides are the same length. As opposed to the rhombus, where you've got all sides the same, you've still got different angles though in a rhombus. So that angle and that one are the same. These 2 are the same. All right, let's fill in the blanks now. So they've all got 4 sides. They have both pairs of opposite sides equal. What can we say about each pair of opposite sides? They are also what? Parallel. Good. The opposite pairs of angles are equal. Yeah, so that's what I've talked about there, what I highlighted in green and pink. The diagonals of a parallelogram cut each other in half. So when they cut each other in half, what that means is take this line, take that line, they're the diagonals. They actually cut, that makes this side the same as that one and the other two. And so we talk about that, they bisect each other. So a rhombus has all features of a parallelogram. So what that means is it is a special type of parallelogram. So a rhombus is actually really important because it's a special type of parallelogram. It's a special type, and it's also a special, well, a kite is a special type, or it's a special type of kite actually. And so a rhombus has all the features of a parallelogram and more. That's how we can distinguish between a rhombus and a parallelogram. It has all sides equal, and the diagonals bisect each other. What that means is these diagonals cross, and they cross at right angles. So each angle is 90 degrees. That is not the case for a parallelogram. You can see these angles here are obtuse, and those ones are acute. So they are not at 90 degrees. And that's another property that we can look at to say, well, this is a rhombus, but that's just your normal stock standard parallelogram. Parallelogram looks like a rectangle just squished. And same with a rhombus, looks like a square. All right, here's the rectangle, here's the square, fill in the blanks, go.
Rectangle or parallelogram.
Good.
However, in a rectangle, all the angles are equal.
Yep, equal or 90 degrees, yep.
Oh, yeah. And the diagonal from 90
No,
degrees.
diagonal is a length, not an angle.
Oh, equal length.
Equal lengths, yeah. So with a parallelogram, these are the diagonals of the rectangle. They are the same length. That's one way we can distinguish between a rectangle as opposed to a normal parallelogram. We can see here clearly that you've got a longer diagonal compared to the other. So the properties involving diagonals, they're the trickier ones. They're less obvious. Okay, keep going. Aoife, you done this? The square? So square has all features of a rhombus.
Also, the sides are all equal.
Yep.
The angles are all 90 degrees.
Yep.
The
Yeah, so in a square, unlike a rhombus, the diagonals are the same length. So that's another way we can distinguish between a square and a rhombus. What doesn't say there is that the diagonals also cross at right angles. Okay, and that makes sense because in a rhombus they cross at right angles as well. Yes. All right, what about other quadrilaterals? We've got this one. Let's go. So trapezium, the only special property about the trapezium is that it has one pair of parallel sides. That's it. Nothing else. A kite, you've got two sides the same, so this is the same as that, that's the same as that. The other property is that the diagonals cross, and they cross at right angles, but they're not the same length. So that's how that is different to a square. And it also has one pair, this pair and that pair of angles the same. That angle and the other one. One pair of angles the same, the other pair not. Another way to distinguish between a kite, a normal kite as opposed to a square, which is a special type. All right, then it continues on to look at more polygons. So you can see where they come up in various places here, and interestingly in nature as well. Let's see if you can write the names. So 5 side is we already said that, didn't we? Pentagon. 6 is the hex. So 7 is heptagon. Sometimes you'll see septagon. What about 8? Octagon. 10 is decagon, yeah. So if we look at a stop sign, what shape's a stop sign? Is it an octagon? Sure. Sure. Someone want to Google it? So here's an octagon. Here's a hexagon. Which one's the stop sign? There's the pentagon. Is it 8?
I don't know. I just see a red sign that says stop.
Stop sign. Eight. Okay, there we go. It is an octagon. All right. Done. Let's go. Name each shape. I think we could name them. Let's move on. Just number 7. This one's interesting. Can be a bit tricky. True or false? I'll give you a minute. A isosceles triangle must be acute angle. True or false? It's false? I don't know. I'm asking you. True? All right, so what type of triangle is this one? So here's an obtuse angle, but isosceles triangle. So yes, false. A square is a regular quadrilateral. So a regular polygon has all sides, all angles the same. So a square is a regular quadrilateral, so that must be true. An obtuse angled triangle must also have acute angles. True or false? It can't have all obtuse angles because the sum, go over 180, so it has to. It has to also have acute angle. What about a rhombus? Is that a special parallelogram?
False.
False? No. So a rhombus has all the properties of a parallelogram. If we go back to these properties up here, it has all those properties. Right? All of those properties, but it also has more. It has the fact that all sides are the same length. It has the fact that the diagonals meet or cross at right angles. That is not true of a parallelogram. So it is a parallelogram. It is actually more than just a parallelogram. An acute angled triangle cannot be isosceles. Yeah, false. We can easily have an isosceles. Look, here's one here. Isosceles triangle that all the angles are acute. A rectangle is a special trapezium. True or false? Yeah, this one's a tricky one. A rectangle is a special trapezium. By definition, a trapezium only has one pair of parallel sides, whereas some people will say a trapezium has at least one pair of parallel sides. So it depends on which definition you decide to go with. My thinking is just one pair of parallel sides. So my thinking is false, but some books will say that's true. I prefer false. An equilateral triangle must be acute angled, has to be, because all the angles are acute. A trapezium must have 2 equal sides. True or false? No. So here's a trapezium. For example, or don't even have to make it right angled, where you've got a different side length. So they're parallel, and then you've got these at different angles and hence different side lengths. So that is still a trapezium. Well, we didn't get all the true false right.